Simcenter 3D is an ideal tool to help you predict performance of cooling systems for densely packed, heat-sensitive electronic systems. Simcenter 3D is an integrated multi-physics environment that can simulate tightly coupled 3D airflow and thermal fluid behavior without having to manually transfer data between solutions. In this demonstration, we start by importing ECAD schematic data using an associative bidirectional data exchange for printed circuit boards, otherwise called PCBs. This allows us to directly generate a 3D assembly of the board and its components. By pointing to a user database of component thermal properties, Simcenter 3D creates a suitable model for each electrical component. The copper trace data imported from the ECAD is used to compute and apply detailed conductive properties to the board thermal models. The PCB finite element model can then be added to this PC finite element assembly model and quickly be positioned into place. We then need to generate the internal and external air domains necessary for a thermal fluid analysis. In a typical CFD workflow, developing the fluid domains can be a very time-consuming process. However, with Simcenter 3D, this can easily be accomplished using a surface wrap algorithm that even works at the assembly level. In addition, we can choose to further refine the wrap by defining a tighter local resolution, in this case around the PCB. This flexibility ensures we produce a mesh that captures details only where needed and does not unnecessarily increase computation time. Because components of the PCB are close to those of the assembly, contact prevention constraints are used to ensure an adequate gap is maintained. All of these constraints can then be added to the surface wrap definition. And finally, the resulting fluid domain is associated to the base geometry. So in the event of a design change, you can rapidly update the fluid domain with little additional effort. The wrap automatically generates a 2D mesh, which is then used to only generate the corresponding 3D solid mesh. Again, the mesh is also associated to the design, so if the PCB design changes at any time, the wrap, 2D, and 3D mesh will always update automatically. Once the internal domain is generated, we can then generate the external air domain around the enclosure. We can then define a coupled multiphysics thermal flow analysis. We can also take advantage